fancy. There we go, that worked. Alright. Alright, so let's do another one from let's pick a different one. Okay, here's an easy one here. So it says this is number 1 on Wednesday. If the PWP 14%. I didn't make it blue on purpose, it's just the pen I grabbed. 14%. We want to know what the PWP is in inches per foot. So all it's asking us to do is to convert it to inches per foot. The way we do that is we take the 14%, which we write as 0.14, we times it times 12. You might say, why 12? Well, there's 12 inches in a foot, right? So, and what do you guys get when you do 0.14 times 12? Can someone do it on the calculator?
Sorry about that.
No.
Slow phone. Times 12.
What,
I get
1.14?
1.68.
1 point what?
0.14?
1.14? And what do you
I
get?
got 1.68.
All right, we need a tiebreaker here.
Sorry about that.
So 0.14 times 12.
Oh my god. I'll go with first.
No, we need the right answer.
1.68.
1.68? Okay.
I got that.
So 1.68. No, I needed a tiebreaker.
Oh, sorry.
Yeah, I
Sorry.
had two answers, so I got to get a third.
Sorry about that.
So what this is saying is that 14% is equal to 1.68 inches per foot. If I was given the number 14%, I can't do a lot with this on a form. I can't apply a percentage, but if I convert it to inches per foot, I can use that. Right? And on a side note, an important number to write down is that 1 inch of water is equal to 27,152 gallons per acre. So we get 1 inch of rain over an acre. Well, this is, how many acres is this farm? 15?
Yeah.
We can figure out right now how much water this whole farm gets per year. So if we know that 1 inch is 27,152 gallons per acre, this farm is 15 acres, right? So let's do this. Well, first thing we know, how many inches of rain does LA get a year? 12 maybe? 10?
Price was that.
Let's just say 10. It's an easy number. So, if we want to figure out on this farm how much rain do we get per year on this total farm, we can actually figure it out. So this is 1 inch is equal to 27,152 gallons per acre. Well, we'll say in LA we're getting 10 inches a year. So that gives us 271520. So the full year over 1 acre is going to be gallons, 271,520 gallons per acre. We know this farm is 15 acres. Do the math there. 271,520 times 15 acres. So this farm gets 4,072,950 gallons per year. So we just figured out what this whole property gets per year. So about 4 million gallons of water. Now it sounds like a lot, right?
But looking at it, no.
Well, when you think about it, so say we had avocados on this, so 15 acres of avocados. Those guys are thirsty plants. So they usually like about 36 inches of those per year. So they want about around 3 feet. Now we'll make this easier. We'll just say 40 inches. So a little over 3 feet of water is what an avocado tree wants per year. We'll obviously spread it out, but so if I need 40 inches of avocado of water per year for my 15-acre avocado farm, I'm getting, 10 inches a year here with rain. I gotta add the other 30 inches of irrigation. But the total amount of water that this 15-acre avocado farm would want would be this times 10 inches times 4. So this was how many gallons we had per year for 10 inches of rain. Avocado wants 40 inches. So if I times this times 4, 16,291, 800 gallons. So we need if this was a 15-acre avocado farm, we need 16 million gallons of water. It's a lot of water, especially because we gotta irrigate most of the water, right? If we're only getting 10 inches in rain, I gotta pay for the other 30 inches, right? And if San Diego has the most expensive water in the U.S., maybe avocados are a bad idea, which is why you see a lot of avocado groves you just see stumps really, or the skeletons. So that's why a lot of times people are switching their avocado trees for more drought tolerant crops. Olive trees do well, certain wine grapes, even citrus isn't this bad. But the idea is, if I'm gonna plant a crop that needs this much water a year, and I'm only getting this much from rain, I gotta supply the rest, and does it actually work?
Or this is just for an example. That's for one tree.
No, this is for like a 15.
Farm,
So if
farm.
we took this whole farm here and just did avocado trees
Okay.
on that.
I've been hard. Okay, sorry about that.
No, that's all right. And so something that, and 15 acres of avocado trees is a very small amount. That's a very small farm. And so, but why do we still see avocado farms around if it's such a thirsty plant?
Money.
Well, they're worth a lot. They sell a lot. But if I'm on a well, do I have to buy that water?
Nope.
Not really. I can just pump it up. And so if you're looking at an avocado grove, like this might be a mistake to buy, but it's on a great well, has a lot of gallons per minute. I just have to pay for the power of the pump, which isn't that bad. Then I don't have to buy all the water. I can actually just get it from my farm itself. So that's why you still see avocado farms still around. And some are even there's even new farms. What they're doing now is when they used to plant avocado trees, we're totally getting off track here, but it's all right. Say these dots are like a tree. So tree here, tree here, tree here. These were 20-foot spacing. Any guess on why they plant them 20 feet apart?
Irrigation.
That's part of it. You're close. I mean, it doesn't need that much space.
Okay.
But when you used to buy PVC, which is the irrigation pipe, it used to come in 20-foot sticks.
Okay.
So when you buy it, it already came in a 20-foot length. So basically, they just put a piece, put a T here, put a piece, put a T here, have your sprinkler go up. But the only reason they were spaced that far is because it was a convenient thing to do. The pipes were already cut to that long. I laid the pipe, put a tree, laid the pipe, put a tree. But as water got more expensive and it became important, the spacing is too far. The trees don't need that much space. And so now what they're doing is they're planting trees. So there are new groves that go up, but now they're doing them at 10 feet apart. And then what they're also doing is normally your avocado tree will, say this is the tree right here, will go up to say 30 to 50 feet tall if you let it go. They're keeping them only like 10 feet tall. So they're making them more like dwarf trees. And what's happening is they're getting double the tree count per acre and way easier to harvest because you don't have to get on a ladder. All right, it's just right there. And so they're getting almost double the fruit for the same amount of water. So now it makes money. So it's something that it goes back to the water is always important. And so what they're doing now, avocados always sell well if you can do it efficiently. So now they're just doing new groves, small trees, 10 by 10, and now we're getting double the trees, the same yield if not more. And so now it can actually work as a farm. So buying an old grove might be great because the tree's already grown, but it might not be worth the money. Also.
Side note, I
Yep.
have to walk past an avocado tree, and I'm so scared of things dropping on me.
The actual fruit or the tree?
The actual fruit. It's,
Okay.
it's like there's so many of them.
And they're heavy.
Yeah.
Yeah, I mean, it probably hurt, but they don't usually fall. They're not really like I don't know, like citrus,
Oh.
you know, which are a lot easier just to pull off.
Right.
Like when you harvest them, you have to use a tool to get them off.
Oh, really?
I mean, they'll fall eventually,
Oh, okay.
but when they're heaviest and they're full of kind of not liquid, but they're heavy, usually you have to have a tool to get them off. It's like a little claw.
It's right on the sidewalk, and I never seen one fall to the ground. But now the season getting there, so I have to wear.
I'll tell you this: I don't think there's any confirmed deaths from avocado fruit.
Okay.
Yeah, I don't think there might. I mean, maybe somewhere in the world, but not here.
Right here. Okay.
If anything, it'll give you a knot on the head, but it's not gonna do damage. If anything, I'd be more worried about the tree.
On your avocado example,
Mm-hmm.
you did the 4,072,950 times
Yep.
40 or times 4?
4, because that 4 million was for 10 inches of rain.
Okay.
So we just times 4 because that's what avocados need. And then obviously that 40 million, you break it down per week, and then now you have a gallons per week. And so if say we had 40 million was our total that the avo wanted, the tree wanted per year. So someone divide this by 52 on a calculator if you have enough space on there. Because that's obviously how many weeks are in the year.
52.
Not saying that's why I had to do that.
I'm like 769,230.7.
769? All right, I'm lost on the number.
769,000.
Okay, so we'll do 770 gallons per week per tree. So a tree wants 770 gallons a week. So we'll divide that by 7. That's
Somebody else was early.
So how many gallons per day?
109 gallons.
Yeah, okay. Figured. That's 110?
Yeah, 110.
Yeah. So 100 gallons per day per tree. So we can work with this. So if I have a sprinkler, right? Sprinklers are rated gallons per hour. Every sprinkler you buy. On a sprinkler will say 2.2 gallons per hour. So what we can actually do is if we take the 110 divided by 2.2, what's that?
Fifty-five?
Let's see if we're doing math here.
50.
110 gallons.
50?
Is 50?
Yep.
50. Or that's not the number I want. 110.
At least you know how to do it on the alphalist or whatever the beads are.
Yeah, I gotta figure out my math. It shouldn't be 50 hours.
110 divided by 2.2
And that's right. I have to
Remember,
double
we
check
rounded
this.
up. We rounded up.
Well, it shouldn't be 50 hours. That's too obviously you couldn't do 50 hours of irrigation one day. 102 gallons. All right, I'll have to figure that out. I don't know why it's not working out.
I think, shouldn't you would have done weeks first? So you should have done divided by weeks first.
Well, I got 770 gallons per week per tree. That gives me 110 gallons per day. And then if my sprinkler's doing, you know what it is? I don't think it's 2 gallons an hour. I think it's 2 gallons a minute. Yeah, that's what it is. It's GPM. All right, that's what it is. So the sprinklers are rated at 2.2 GPM, gallons per minute. There we go.
Wow.
Okay. So if we do 110 divided by 2.2, we got 50. So that's saying 50 minutes per day. All right, so that makes more sense. Okay, that's the part I got messed up. This part. So now I just go to my timer, say, hey, on 1 hour in the middle of the night, daily, and now I reach my 40 inches a year. So kind of went through like module 3 math, but it made more sense when you guys can see this is what we can actually use on a farm. I can't really use 1.68. It doesn't do anything for me. So the idea is that if we can figure out how much the actual crop needs, figure out the flow rate going to the crop, we can actually figure out, well, how long do I set my timer for? Because that's all we want to know. Is really when I go to my timer, I tell it to kick on for how long. And then obviously if there is a rainy year, you get 20 inches of rain, we can just adjust it. So instead of doing an hour, maybe we do 30 minutes. So, but this is something you would calculate for if you're buying a farm, especially one that's already established. Especially if you're gonna be able to afford the water, because what we used to do just kick them on until the ground was wet, and then we'll turn it off when it's all done. So, all right, you guys head hurt yet?
Yep.
Just a little bit.
That's gallons per week per what?
Yeah.
Which one? This one?
Yeah.
Gallons per week per tree. Yeah, per tree. Yeah, sorry. That's right. Then gallons per day per tree. And then our flow rate for our sprinkler, which can change, 2.2 gallons per minute. And we got our 50 minutes per day. Yeah. All right. I think we're good here. Let's do one more equation, and then we'll turn the math filter off. Let's do one more here. Okay, so this is number 5 on Wednesday. Okay, so if the AW is 1.3 inches per foot, what is the PWP? It wants it in percent. If the FC is 22%. And here's the thing, is that my units are different here. All right, I got percents and I got inches per foot, and I think it's easier if you either have it all apples or all oranges. So what I'm gonna do is I'm gonna change this 1 inches per foot to a percent, just so they all kind of match here. You guys remember how we do that?
No.
Okay, so what we would do is we take the 1 point, if we're going from inches per foot to a percent, we're going to divide. And then if we're going from percent to inches per foot, we're going to multiply. Just kind of a side note there. So if we're going inches per foot to percent, we'll take the 1.3 inches per foot. We'll divide it by 12, and what do you guys get when you divide it by 12? You guys can use a calculator too if you want. If you guys doing it by hand. I haven't done it by hand in years.
Like 0.108. Maybe I got that wrong.
Just do two spaces. Point something.
Okay. Yeah. I got like 0.0. I don't know. I'm sorry.
Okay. Anybody else?
0.11.
Okay. So 0.11, which we know is 11%. So now we will change this to 11%, and now this will be easier to solve. So we take our equation, FC minus PWP equals AW. We got the FC already, so 22%. We're solving for the PWP, and we know that it equals 11%. Now, the one we don't know is PWP. We call it the variable, so we don't know what it is. You want the variable always all by itself on one of the sides of the equation. So our goal is to get this guy alone. So the way you do that is you move the guy you do know to the other side. All right. We know this is a positive just by default. So if we want to move this over here, we do the opposite. We subtract 22% on both sides. That means these cancel out. I'm left with a negative PWP. What's 11 minus 22?
A negative.
It's a negative 11. And then what happens when you got a negative sign on both sides of the equation?
Divide by -1.
No, don't go that far. You just erase them. That's what you're doing. Okay. So if you have a negative sign on both sides, you can just erase them. Our PWP is 11%. Okay. A little bit harder, but just think we want to get the units to match. Our AW was in inches per foot, so we got them all to be a percentage by converting it here. Once we got that, we got our formula, FC minus PWP equals AW. We plug in what we were given over here. We plugged in the 22%. We're solving for PWP. It gave us 11. The PWP is a variable. I want to get that alone on one of the on one of the sides of the equation. So I need to move this 22 over. It was a positive, so to move it over, I got to do a negative, or the opposite. And then when I did that, PWP was alone. It had a negative here. 11 minus 22 was a negative 11. But if I have a negative sign on both sides, I can just erase it. There is arithmetic on how to erase it, but it doesn't matter to you guys. Just erase it. As long as you got one on both sides. So this is number, what was this? 5 on Wednesday. So our answer is 11%. Are we all right? Okay. I don't see any smoke coming out of your guys' ears yet, so we're in a good spot. Okay. So on your little cheat sheet, you should have this formula here, and then I would also put the percentage to inches per foot times 12 inches per foot to a percentage. We divide by 12. So you can just write these probably on the front page of your binder or something, and we'll have some more of these as we're going through. But it's easy to look back on if you already have it. Okay. I think we'll go from that. Any other questions, guys? So the math you guys have here, let's have it completed, and we'll bring it in as a hard copy next class. All right, so we'll have a week to do it. If all else fails, you just can't do it. Just bring it anyway, and then we'll work through it. The whole idea is we're not trying to fail the class because we can't get to the math. The math is important, but it's not a deal breaker. So, but I feel like we can get through it. We'll take steps, and then if you're good at math, then classmates not that great, we can help each other out on this. So, all right. I think we're good